I'm Seokhyun. Today we will talk about optical devices. First, we will talk about surface reflection. Surface reflection is a sort of reflection that when the light or energy is injected to the device, as we know, the 100% light can't inject it to the device. In other words, there is also the transmission. So the reflection coefficients, reflection plus the transmission equals to 1, the in terms of the percentage. Next, there is absorption coefficient, which means that how well the devices can absorb the energy. If the absorption coefficient is big, it means the device can absorb well, and if the coefficient is small, the device doesn't absorb light well. There are quantum efficiency and responsivity. The quantum efficiency eta Q, it means how much the current occurs when occurs compared to the input flux, and responsivity means how much current occurs compared to the input power. And there is fill factor. Fill factor means the fill factor is about the current and voltage, so it can relate it to the power. The power current max multiply voltage max is equal to the max power, and short circuit current multiply open circuit voltage is the max power in ideal. So fill factor equals the max power over the power in max power in ideal. So fill factor is smaller than 1. Next, there is power conversion efficiency, the eta. Eta is the percentage of input power. So as is equation, the eta equals the fill factor and fill factor multiply short circuit current multiply open circuit voltage over power in ideal. Next, there is pin diode. Pin diode is PIN, the P type, N type, and between them there is intrinsic semiconductor. So why we made this is because we should make the depletion region larger to make the bigger potential drop. But in basic PN junction device, it is smaller than its depletion region is smaller than PIN diode. So to make potential drop at intrinsic semiconductor, we should make PIN diode. Next, LED. At PN diode, we apply the forward bias. Then the P-type energy can be lower and N-type energy become higher, so the barrier becomes smaller, so it can be the recombination. By this, to make recombination more frequently, we sometimes make potential wells to get more carriers, and it occurs, it generates the recombination more. And next we will talk about the AM OLED, the active matrix OLED and passive matrix OLED. PM OLED, to operate the PM OLED, we should choose the diode and put the signals in like two-dimensional, but it's hard to make bigger devices, because when the first one operates and second one operates, the first one is off, so it is hard to control, and to make bigger one, it costs very much. So we use AM OLED. It is more effective. Next, the population inversion. Population inversion is the unlike usual, the higher energy state electrons locates more than the lower energy state electrons. So by applying the energy or light, the higher state of electrons can go up slightly and go to the lower energy. It causes the stimulated emission. So when we if we match the time, then we can make the higher power of light wave, because the coherent light can make bigger light. So for laser, the two components is important. First one is coherent light wave, and second one is population inversion. By this, in laser diode, there is we dope two side PN much, doped much, and then if we apply the forward bias, then the energy gap, the energy barrier gets smaller, and in here at depletion region there is a recombination. And last, there is an image sensor. First is CCD, charged couple device, and CIS, CMOS image sensor. The principle of CCD is applying first, second, third parts in order, so the carriers can move to the next. And CIS, it is related to the transistor, so when light is applied, the respective transistor can do their work in order, so it can make the image